My name is Hamid Keita. Today I'm going to talk to you about Unit 2, which is about millions and billions and trillions. And I'm going to walk you through some work example that will help you if you're doing a collaboration on this particular module or unit. We're going to be diving through some large numbers. Okay, so to get started, we're going to talk about some large numbers here, millions, billions, and trillions in your collaboration. So these are work examples that I believe if you follow, you will be able to do your collaboration easily, because we're going to discuss most of the examples you have in your collaboration in this video. So the goal is to explore these numbers and learn some quick way to estimate large numbers without um, punching uh, for exact number all the time. You can make some quick estimation um, with this number if you understand place values. So understand these large numbers is important because you see them everywhere in financial report, in government budgets, and population data. So it's important for you to be able to mentally, um, estimate these numbers and see if they make sense. So why is the collaboration part of this unit important? Well, these large numbers, as I say, they appear everywhere in the news, and they are so large that it's sometimes difficult to conceptualize. When you learn some estimation strategies, you can develop a sense of scale and improve numerical literacy. This skill is useful in economics, statistics, and everyday decision making. So before you start your collaboration, it is important for you to go through the preparation part of the unit, because the preparation part of the unit allow you to dive into some calculations, and that will teach you some estimation techniques which you can then apply in your collaboration. So so make sure you walk through the preparation before you start your collaboration. The preparation also help you to estimate quickly and assess how reasonable these large numbers are. If people are claiming something with this, large numbers, you can run some quick estimate to see whether it makes sense or not, whether it's reasonable or not. It will also allow you to recognize decimal places, which will help you to compare large numbers effectively. So here's an example of some large numbers, and we can quickly apply estimation strategies. So consider this number. This is 120,000. You add 10 to that, you have 1.2 million. You add another 0 to that, you have 12 million. So just by putting an extra 0, the scale of the number changes significantly. So it's important for us to know place value. The reason why the numbers are different is just because of 10. So understanding place value will really help us to conceptualize big numbers. So the number of zeros indicate whether the value is in the 100,000, millions, or tens of millions. So if you can quickly recognize that, you'll be able to kind of attach a value to that big number, whether it's a billion or a trillion or 100,000. And this is important if you're analyzing financial data, population data, because they are big numbers. So figuring out the number of zeros will help you to figure out where that large number lies. Is in thousands or millions or billions or trillions. Okay. So we will walk through some work example for your collaboration. So here's the first problem. How much is a trillion? Okay, problem situation. How much is a trillion? So first, as a student, estimate and explain your strategy before you start calculation. So the first question is about minimum wage. There are 1.1 million minimum wage workers in 2020. And if each work 40 hours per week, each of these minimum worker works 40 hours per week and 52 weeks per year, how much money would be needed annually to raise wages from 7.25 to $15 per hour? So we really have to make sure we understand the question here. So what we are trying to achieve here is that we have 1.1 million people who are earning minimum wage at 7.25 in 2020. So let's say we want to help these people out. We want to increase their minimum wage to $15 per hour. They'll be very happy. But we need to come up with extra money to be able to pay for that difference, okay? From 7.25 to 15. Okay, so we're currently paying them at 7.25. We want to raise that to $15 per hour. So there's a difference there. So this question is asking us, what is the total amount of money in dollars that we would need to increase their pay from 7.25 to $15 per hour for all the 1.1 million workers who were earning minimum wage in 2020. Okay, so we have to identify some information from this question first. Okay, we have to identify some key information here, and then from there we can begin to solve the problem. So we have population working at this rate is 1.1 million, okay, and they work 40 hours. They work 40 hours. Per week. Okay, let's say they work 40 hours per week, and there are 52 weeks in a year. Okay, so we have 52 weeks. 52 weeks in a year. And their wage, so their current wage is 7.25, 7.25, and we want to take that to $15 per hour. So from 7.25, we want to raise that to $15 per hour. $15 per hour, okay? And this is $15 per hour. Okay, so we kind of have all the information here. So what should we do now? Well, one important step that we need to do is now we have all the information here. We need to figure out exactly what is the difference between 7.25 and 15. Okay, so that's what we need to do here. So the next step is to know the difference between 7.25 and 15. So we just say 15 minus 7.25. So that gives us 7.75. So what is this 7.25? 7.75. This number right here means that every hour we have to pay each worker an extra $7.75 in order to raise their minimum wage to $15 per hour. Okay, so now we have a very crucial information here. We know that we need to pay 7.725 extra per hour, and these folks work 40 hours per week. And we know that there are 52 weeks in a year, but we also know that we don't have only one person. We have 1.1 million people that we need to pay this 7.75 per hour in order to raise their wages. Okay. All right. So now we are going, let me just clear this. We are going to walk through 7.725 is the original payment per hour. And then 7.75 is the extra that we have to pay for all the 1.1 million workers. Okay, so now we know this 7.75 is the amount that we need to pay per hour for each worker. So now it becomes, all right, so you work for 40 hours. Remember the information I gathered from the questions, 40 hours per week. That's what they do. And there are 52 weeks in a year. So 40 times 52 is going to give us the total number of hours these workers will work in a year. Okay, so this is the total number of hours each worker will work in a year if they continue to work 40 hours per week, and throughout the year they will clock in 2,080 hours in that year. Okay, so we know the total number of hours per worker So the next thing we need to do is um, to calculate the 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 increase in wage or the additional wage, the 7.75 that we need to pay per person. So one person, what should we pay them if we add 7.75 more to their minimum wage? So that's going to be this hour, because this is the hour each worker is clocking in a year. That is the 2080 times 7.75. 7.75 is the difference between 7.25 and 15, right? So 1 year worth of work is this 2080 hours. The difference between 7.25 and 15 is 7.75. So if you multiply that, you have $16,120 per worker per year. Okay. So if we decide to raise the minimum wage to 15, this is the commitment we're making to each worker, that in addition to your 7.25, we are going to pay you an extra 16,120. Okay, so this is just for one worker earning minimum wage, and we want to top their wage from 7.25 to $15 per hour. Okay, so this is just one worker. So now, from the question, we say there are 1.1 million people that are earning at minimum wage in 2020. So if this is one worker only, we need to figure out how much in total will we pay for the entire 1.1 million worker. So now we have good information about how much it's going to cost per person per year. So we just need to multiply that by 1.1 million people. So this 1.1 million, we also have to make sure we write this out. Okay, so you want to make sure 1.1 million, right? So 1.1 million, which is the same as 1,100,000. So that's 1.1 million. So it's important for us to write this out if we are multiplying by other numbers so that we get the right decimal places. So 1.1 million, this is how you write that, times 16,120. So the 16,120, that's the amount we're going to pay per person in order to raise their wage. Remember that. So we're gonna have to multiply the 16,120. So this is in dollars, $16,120 times 1.1 million people. Okay. So, you can pull out your calculator and punch these numbers, and you will get 17 billion 732 million. Okay, so that's what you have. All right. So um you can instead of writing all the zeros, we can just put a quick estimate here. So the estimated total cost to raise wages to $15 per hour for the 1.1 million minimum wage worker in the US would be about 17.73 billion. Okay, so this is 17.73 billion. Okay, so this is 17 billion and 732 million. So that's how you write it. So this is 17.73 billion. Okay. Okay. All right, so we got that. Um, so we can move on to the next question. So the next question here is, if you're to buy everyone in US a box of cookies, right? And each box costs about $5. And assuming that the population is 334 million people, how much would this cost you? This would be a straightforward work here. So we just need to know how much it costs per box of cookie and the population that we're going to serve this. Okay, so that's indicated in the question. So $5 per box and 334 million people. So if we were to buy a box of cookies for 334 million people, how much would that cost us? Okay, so we have to gather some information here. So the cost is $5 and the population is 34 million. Okay, or right, so it's important if we are performing a multiplication or any operation that we write out the numbers, not just 334 like this. So we want to say it's a million. So that means we have to add the 6 zeros, 334, say 334 million. So we're going to add the 6 zeros. Okay. So that's the number. So to figure out the total cost, we're going to have to multiply the cost per box times the population. So that's going to be 5 times 334 million. So if you do that multiplication, that's going to be 1,670,000,000. That will be 1.67 billion. That's what it will cost you. This one is just a random number that appear here, so this shouldn't be here. So this question really just need to know the cost of a box of cookie and the population. So you just multiply them and you have this number right here, and we can rewrite this as 1.67 billion, right? Okay, so our next activity is for you to try some problems on your own. So try the yourself question. Here, students should pause the video. So pause the video and perform this calculation. So the first question is to estimate the total cost of providing every US household with a 1,400 stimulus check, assuming that The total household is 130 million. Question number 2, find how long it will take to count to 1 trillion if you counted one number per second. So you're counting one number per second. So 1, 2, 3. So you want to count continuously to 1 trillion, and it takes 1 second to count each number. So how long would it take you to do that? So do your estimation and calculate those answers, and the answers will be provided by your instructor. We can also provide the answers in the attached to the video. Okay, so next question, question number C, is about public college tuition fee for 4 years. Okay, so in 2021, there were about 14.63 million college students attending public universities. If the tuition is 25,000 per year, what would it cost for 4 years for all these folks? Like, how much if I were to pay for the tuition fee of all the 14.63 million people, and it costs 25,000 per year, how much would that cost in total for all the students? So that's what we're trying to solve here. How much does it cost one student to attend this public university for 4 years? Okay, so that's what we need to figure out. And once we get that, we will then multiply that figure by 14.63 million, because that's the total number of students attending public universities. So we just need to know the cost per student for 4 years, because that's how long it takes to complete 4-year university in an average. So in 4 years, it's gonna cost $100,000 because 1 year is 25,000. That's the tuition per year. So 4 years is gonna be 25 times 4, which is straightforward, and that's gonna be 100,000. So now we know it's going to cost each student $100,000 over 4 years to attend public university in 2021. So now that we know how much it costs per student, we can do some calculation to figure out how much it would cost for the entire 14.63 million people. So we're going to say 100,000, which is the cost for one student to attend public university for 4 years, times 14,630,000. So it's again important to make sure that the 14.63 million, we write out all the numbers, okay? So if we multiply 100,000 by 14,630,000, that's going to give us some big number, but we can also do some quick calculation here. So 100,000, we can write that as 10 to the power 5. Okay, because we have 1.0 times 10 to the power 5, so there are 5 zeros. Okay, for the 14 million, it's going to be 1.4. So we have how many digits here? 1, 2, 3, 4, 5, 6, 7. So that's going to be 10 to the power 7. All right. So now we just need to say, if we are multiplying these two numbers, the 100,000 and 14 million, we're going to say here 1 times 1.463, which is the same as 1.463. But their powers, if you are multiplying their powers, as you learn in other topics, that means we have to add the exponentials. Okay, we add the exponentials. So adding the exponential will give us 10 to the power 12, 10 to the power 12, 1.463 times 10 to the power 12. So that means the total we're going to get is going to be in trillions, because 10 to the power 12 is a trillion. You can also use your calculator right here to just do the calculation. 100,000 times 14,630,000. You're going to get the same answer. But this is even a simpler way of estimating without using a calculator, because once you use these exponentials, you can easily multiply 1.46 times 1, right? Easily. And then the exponential will just add 5 plus 7, which is going to be 12. So your final answer for the total amount of money you're going to need for all the 14,630,000 is going to be 1.463 trillion dollars. That's what it will cost you. The final question that I'm going to walk you guys through is about national debt. Okay, so you all are aware of national debt. The US has significant amount of debt. So this question is about national debt. If the US national debt was 30 trillion in 2022, which is true, and the population was 334 million, so how much of that debt, if we divide it among the population, how much is each person responsible for? That's what we are calculating here. So we have 30 trillion in debt and the population is 334 million. If we are to share that, how much is every citizen responsible for? Okay, so let's gather some information here. So we said in 2022, the national debt is 30 trillion with 12 zeros, and the population was 334 million people. Okay, so it's important for us to write out these numbers because we're dealing with large numbers. Let's write out the numbers. So 30 trillion is the same as 30, and we're going to add 12 zeros, and 334 million is the same as 334, and you're going to add 6 zeros because that's 6 zeros is a million. Okay, now we get that. This question is really dividing the debt by the population, which is 334, and that's going to indicate how much debt is each citizen responsible for. Okay, so if you write it out like this, you could simply do division by saying, okay, so we have how many zeros here? You could cancel the 0 with these 3 zeros. These 3 zeros will cancel these other 3 zeros. This makes it easier to do the rest. So I'm just gonna punch, because sometimes if you have one of those simple calculators, you might be able to get to write all the 30 trillion. It's just too much for some calculator. So, but if you just cancel this out, you're left with 30 million divided by 334. Whatever you get is going to be the debt per person or the debt per citizen that they will get by dividing the national debt. Okay. So you can do the division. If you do the 30 trillion divided by 334 34 million people, that's going to give you 89,820.36. So that means $89,000, 820 per person. Okay, so going by the 2022 debt, if you divide it among citizens, everybody is going to be responsible for paying $89,820.36. So here is another question for you guys to try. Okay, this is a fun one. So pause the video and see if we can get to the answer. The question is, how long will it take to watch 1 billion TikTok videos if each video is 15 seconds long and you watch this nonstop? So you're just watching nonstop until you get 1 billion TikTok videos watched. How long is that going to take you? Okay, so this, you gotta, gather some information. You have 1 billion TikTok videos to watch, and each video is 15 seconds. Okay, one video is 15 seconds. So, and you want to watch 1 billion videos. So you might want to, at the end of the day, you want to convert seconds to minutes, minutes to hours, hours to days, days to months, months to year, and eventually gonna put your answer in year. How many years or how many months is it going to take you to watch all the 1 billion videos that are 15 seconds long? So to wrap up this video, this process took you through some estimation strategies, working with large numbers. So it's all about understanding place values, the numbers that comes after um, the zeros that come, decimal places basically. They make a whole difference. If I add a 0 to 100,000, that's 1 million, right? And the difference between 100,000 and 1 million is 900,000. So just adding one zero significantly um, change the value of that number. So we have to be aware of the decimal places or place value. So here we were also uh, able to understand the difference between millions, billions, and trillion, and we use some um, simple ways to estimate and evaluate these numbers, so that um, we can easily do a quick estimate about any claims and see whether it makes sense to us. Because sometimes you hear a lot of big numbers in the news, so being able to quickly estimate, run some numbers and making sure that what they're saying makes sense to you is important life skill. So this skill you can apply them in everyday life, government budgets, healthcare costs, economic policy. All these involve, big numbers that you need to understand these estimation techniques to make sense of. So we have really developed a stronger intuition for large numbers and estimation strategies. So anytime you hear these big numbers, now you know how to quickly estimate them and assess whether they make sense to you or not. So if this video makes sense to you, make sure you comment in the comment section and let me know how it helped you in your collaboration. Thank you very much.